Alright guys, we're going to have an introduction to simple harmonic motion and wave basics. So what this unit is going to cover is the motion of waves and characteristics of waves. So this is just your introduction. It's kind of explaining sort of what we're doing, and then we'll do some sample problems. So let's start with the first page. So a couple things to know. Period, the time it takes for a vibrating object to repeat its motion. And frequency, the number of vibrations per unit of time. The variable for period is a big T. The variable for frequency is an F with a little curve. Down here, let's skip these formulas for a second. Just to denote, period is a measurement of time, so it's SI unit. Like the standard unit it'll use will be a second, right? And frequency, the SI unit is going to be hertz. So if they give you hertz, you know they're talking about frequency. Right? So, let's take a look at a wave. I made this wave here. It's really good. Let's take a look at it. Hopefully this explains it a little bit. This wave happens over a 1 second span. Right? So this right here is an example of a period. The time it takes for a vibrating object to repeat its motion. So this is our vibrating object. This is the single motion. It goes up, down, back up. That's its one motion. So this time is called a period. The frequency is the number of vibrations per unit of time. How many times it went up, down in this given time. In this case, our frequency is 3 cycles, which is going to be 3 hertz. So the next thing that they're going to go over, and we're going to go over in this unit, is Hooke's law. Hooke's law has to do with springs, kind of like a slinky, and how they restore themselves to equilibrium, which is like their normal resting balance state, right? So let's kind of go over some of this. So when a spring is stretched from its equilibrium position and released, it's going to move back and forth until it reaches that normal natural resting equilibrium. The force that pulls it back and forth and attempts it to restore itself to the equilibrium, it's called the restoring force. So this is very important. And the magnitude of the restoring force is written as this. So this is our formula right here. So that being said, let us write the formula. I'm going to write it up here. The restoring force equals K times X. Restoring force equals K times X. So let's talk about what that is. So, F in this formula is going to equal the restoring force, as they just said here. K is going to be the force constant. And then X is the displacement from the equilibrium. So let's talk about these real quick. We just talked about the restoring force, which is the force that pulls it back and attempts to restore the spring to its natural position. So you have a slinky here. You stretch it to the left. The force that wants to pull it back to the right, and it bounces back and forth till it rests, that's called the restoring force, which we're going to try to figure out in these examples. The displacement, well, remember, that just means like how far from the initial point. Okay? And then the force constant is what they'll give you. Okay. So let's talk about the force constant. We haven't talked about that yet. The force constant, as we see right here, is the measurement of the stiffness of the spring. Typically, they're going to give this to us in the problem. Sometimes we might have to solve for it. And it's going to change because every spring has a different level of stiffness. If you play with a slinky, you're going to be able to move that around and manipulate it because it's relatively loose and supple. But if you're looking at something like the shocks of a car that need to be a little stiffer and aren't very movable unless they have a lot of force added to them, that's going to be quite different, right? So the force constant is going to change from object to object. So let's finish up our introduction about talking about the period again. If you guys remember, the period is the time it takes for a vibrating object to repeat its motion. So in something like this, which would be like a spring mounted to a wall with a weight on it, it would be the time it takes for this object to go down and then come back up, right? So some things actually affect the period. Now, in something like this, 2 things will affect the period. And remember, the period is the time it takes to go down, come back up, or the time it takes for a vibrating object to repeat its motion. Now, two things that will affect the period in something like this will be the mass, is one of them. So in the mass, for instance, if you increase the mass, you are going to increase the period. Okay? So more mass equals the longer the time it's going to take to come back to its original starting point. Now, another thing we can do is to decrease the period is to actually increase the spring stiffness. And if you guys remember, K, our force constant, is actually the stiffness of the spring. So you're going to have some questions, and we'll go over those examples in a little bit, where they talk about, so it might not necessarily be this mass spring oscillator, but maybe it's just a scale. Maybe it's somebody stepping on a scale. When they step on it, you know, their weight's going to kind of oscillate a little bit. It's very quick, but until it reaches that equilibrium again. And their weight or their mass is going to affect the period. So as we said before, if you increase the mass, you're going to increase the period, the length of time it takes for the vibrating object to repeat its motion or like go up and down. And if you increase the stiffness, you will actually decrease the period. So if it's stiffer, it's going to go back up and down very quickly, right? So those are a couple things to consider. We'll have a few example problems here in a second. Hopefully that made it a little bit easier. It's a little confusing, but hey, just go with it. You have your formulas in physics. You just look at your formulas, look at what you got, and you plug in what you got, and then you solve and use your basic algebra skills. So you guys are going to do great. Hopefully this helps. Let's rock and roll.